All right, so let's begin. Let's begin. So we are going to make some decisions, and we have different state of nature and different decision alternatives. The decision alternatives are D1, D2, which is D1 is apartments, D2 is office building, and D3 is warehouse. The state of nature are S1, S2, you can have S3, S4, S5, and things, but we just want to deal with these. The S1 deals with a good economic condition. So Kofi Wayo has a good economic condition, and then S2 deals with a bad economic condition. If the economic conditions are good and he invests in apartment building, he's going to make 50,000. If the economic conditions are bad and he invests in apartment building, he will rather make 30,000. If the economic conditions are good and he invests in office building, he will make a whooping 100,000. But if economic conditions are bad, he will make negative 40,000. Remember, all amounts are in thousands of dollars. If economic conditions are good and he invests in warehouse, he will make 30,000. If he invests in warehouse, but economic conditions are bad, he will make 10,000. This information is usually given to you. Okay. Now the question is, which one should Kofi Wayo go for? What should be the decision alternative he should go for? Should he invest in office building? Should he invest in an apartment building or office building or warehouse? Let me ask you, who can tell me? Where should he invest in right now? Should he invest in apartment, office, or warehouse? Let me see. Apartment, office, or warehouse? Perpetua.
Office building.
Why?
Because under the office building is 100,000 cedis.
Okay. What about you, Efia? What should we invest in?
So if I am considering that in all situations, I don't want him to make a loss. On the face value, I would go that he invests in apartment buildings, because whether the conditions are good, he's going to make a profit.
Very good. So that's the point I'm looking for. So you don't even have to answer. You have to simply say that it depends on the state of nature.
Oh, okay.
Which is what you are trying to rather use to answer. So it depends. You can't tell now. It depends on the state of nature. Because if the state of nature is good or bad, the outcome will be good or bad. That is why we need a metric, a method. Okay, so the state of nature would determine this. Now watch this. There are several methods to look at this. The first one is Maximax method. Maximax. Okay. There is another method that we'll be looking at. Okay, and please note that all of these methods, okay, not all of them will do though. The next method is Maximin. Maximin. Another method we're looking at is Minimax. Okay. Minimax regret. It's another method. All of these are going to be used to determine what this guy is going to go for. You have the Howey's. Okay. The Howey's method. And then you have the maximum likelihood or equal likelihood, not maximum. You have the equal likelihood. And there are several other ones. So what we are going to do is that we're going to look at 3 of these methods. Okay. But note something, that these methods do not have probabilities. So what we are doing right now we are doing decision making without probabilities. And we'll come and later explain what I mean by without probabilities. So we are going to look at the Maximax, the Maximin, and then the Minimax regret. The Maximax, the Maximin, and then the Minimax regret. Now let's start. I'm going to use the Maximax approach to determine. Let me explain a little bit about the Maximax approach. Now, when you normally look at the Maximax approach, the max is important first before the maxi. The end is important before the beginning. So you deal with the max first before you deal with the maxi second. When you're looking at the Maximin, you deal with the min first before you deal with the maxi. Okay. Now, what is the Maximax approach? The Maximax approach is also called the optimistic approach. The optimistic approach. Let me put that down. Optimistic. Now, when we say someone is optimistic, what does that mean? Someone who is optimistic. Well, you know, that means the person is confident. So such people, they go for the best of the best. They assume that the economic condition is going to be best, and therefore they choose the best. So such people go for the best of the best. So first, they assume that the economic condition is best. So they'll stay on the economic condition is going to be best. In this case, it's going to be good. And then based on that, they select the decision alternative that is the best. So let me go back to the table. When you look at the table, which decision alternative will the optimistic or the Maximax criteria select? Abigail.
They'll be selecting the office building.
Okay, exactly. So you will indicate that, first of all, the person will go for the good economic conditions. So we stay here. So what you will normally do is that you will indicate that based on the fact that he's going for the good economic condition, such people will go for, I'm just showing you how you write it. D1 will be 50, D2 will be 100, and D3 will be 30. Is it 30 or 40? Yeah, 30. And then out of this, okay, the best decision will be D1 or office building. And you have to give the reason, okay, because it has the highest payoff, okay, of $100,000. It has the highest payoff of $100,000. Now, please note that these payoff are positive. The higher, the better. They are not cost. Suppose these amounts that you are seeing here were cost. You will not select 100. You would have selected what? You will not select decision 2. What would you have selected? Suppose these were not revenues or payoffs. Sorry, suppose they were not revenues, but they were costs. Exactly. I'm seeing some of the answers being there. You select 3, D3, the warehouse. That's what you would have gone for. So please note that the payoffs here are revenues. The payoffs are not costs. And please note that the word payoffs is not always positive. It's not always a positive value. It can also be a negative value. So a payoff can be cost and a payoff can be revenue. Okay. The next approach. The next approach is known as the Maximin approach. The Maximin approach. The Maximin approach is pessimistic. Okay. A person who is pessimistic. Now, a person who is pessimistic will not go for the best of the best, but that person will go for, let me see whether somebody can type that. That person will go for the best of the worst, not the worst of the worst, of course, nobody will. Okay, so the pessimistic person goes for the best out of the worst. So you see, such people, they are very, very careful. So they don't know whether economic condition is going to be bad, but to them, it's going to be bad. Because they've looked at the terrain, COVID, war, and things. So situation is going to be bad. So they will just select the state of nature they don't have control, the bad state of nature. And then based on the bad state of nature, these people will now select the best out of the worst case scenario. That's what they do. They select the best out of it. So when you now use the pessimistic approach, which decision would you have to select for Kofi Wayo? You can tell us. Let me just go back here. Which decision would you select for Kofi Wayo if you go for the Maximin? And note the keywords, Maximin. Which will you go for? Will you take decision alternative D1, D2, or D3? Of course, don't do lottery. D1, most of you are typing D1. Okay, exactly, that is the right answer. So these people, the D1, okay, is 30, that's a worst case scenario. The D2 is negative 40. The D3 is 10. And so such a person will select, this is a worst case scenario. And out of these, you select the best of the worst. And the best of this is D1 because it gives the person $30,000. So using the pessimistic approach, you select apartment building. Please note something. The first approach, you selected office building. The second approach, you selected apartment building. Keep track of what we are doing. Okay. Now, let's go to the third approach. The third approach is known as the Minimax regret. The Minimax, this is a little bit complex, so pay attention here, please. The Minimax regret approach. What is the Minimax regret approach? There's another name for these people, okay, who go for this approach known as the Minimax regret approach. We call this thing second guessing approach. Second guessing. Now, let me ask you, if the investor had bought the apartment building alone, do you remember the one who was pessimistic? Okay, he was pessimistic. And because he was pessimistic, he was very careful. And so he chose the apartment building, which was giving 30,000. And that was because he assumed that economic conditions were going to be bad, all right? Now, what if now we are in the current and the economic conditions were not bad after all, it was rather good? How do you think that person is going to feel? That person will feel regret. The person will regret for not buying what? You can tell me. The person will feel regret for not buying what? I'm getting some answers there. The person will feel regret for not buying the office building. Because see, these people, we call them opportunistic. So the approach is sometimes called opportunistic approach. Opportunistic. Not optimistic, not pessimistic, but opportunistic. The person will feel regret for not going for the office building and getting the 100,000. So what will be the degree of the regret? Who can tell us? How much will be the degree, the quantum of the regret? How much would that be? The quantum of the regret. It will be the 100,000, okay, minus what he has now, the 30,000. So the quantum of the regret will be the 70. So this guy, because he doesn't want to regret, they decide before the event occurs and they calculate that into the decision. These are people who will normally, we call them stock market people. They normally want to, they are very careful in investing in the stock market. Very, very, careful. And so they study the stock market. And then when people are selling high, then they will do low. They avoid the regret. And so they minimize their maximum regret. They minimize their maximum regret. So that means that they need to find their maximum regrets in the first place. Then they will cut that down. Yes, Princess.
Sir, please, can you please take the regret again? Like, I'm not really getting it well.
Okay, I'll take it again. So a person, so remember this approach is known as the minimax regret. Watch the word minimax. Max the meaning. Max the meaning. So you first want to know your regret. First of all, you regret if you had bought the apartment at 30,000. If you had bought the apartment with the intention of getting 30,000, and yet you saw that had you invested in the apartment, you would have rather gotten 100,000. It's like those people who put their money into that guy who squandered people's money. What's the name? Zoop, is it? What's that guy?
No.
What?
Nam1.
Opele Nam1. Okay. So this guy, people thought they were going to get a lot of money, and yet they didn't get a lot of money. And so you don't want to act like that. So what you do is that if you had put your money and had gotten 30,000, and you realize that you could have gotten 100,000, you will feel regret for not getting the 100,000. And the degree of your regret will be what you got, okay, from what you should have gotten. And what we are saying is that these opportunistic people, because they don't want to regret, the first thing they now do is what I'm about to show you. They calculate their regret. So they calculate something we call regret. The regret they calculate is given by the following. Rij equal to, I'll explain all the times. Rij equals to Vj star minus Vij. Vj star minus Vij, the absolute value of that. What is the Rij? The Rij, I want to rewrite it somewhere here. The Rij is your regret. Each decision you take, you're going to regret something on that decision. So you're going to calculate that regret. But how do you calculate that? First, you take your Vj. The Vj is the highest amount in that state of nature. I want to repeat. The highest, okay, amount of the state of nature. So the state of nature is Sj. Good condition, bad condition. So when you look at the state of nature, now let's go back to the state of nature here. When you look at the state of nature under good, there is a highest value there, isn't it? When you look at state of nature under bad, there is a highest value there. So that is going to represent the Vj. J always means column. I always means row. So when you look at the J, you're going to calculate the highest in each state of nature. Then the Vij is each amount, each space. So the Vij's are every amount. So the 50 here is Vij. The 100 is Vij. 30 is Vij. 30 is Vij. Negative 40 is Vij. 10 is Vij. So the first thing you got to do now is to create a regret table. How are you going to create a regret table? You got to create a regret table that will match each of the table that you see right here. You're going to create a regret table for it. And you are going to use this formula to create a regret table. You're going to use this formula, which is the Vj star minus Vij. So how do you get a Vj star? Well, there are two columns. So let's take the first column, Vj, I'll call it V1 star. And then the Vj, I'll call the other Vj V2 star, because there are two columns there. So we're going to calculate, find the value of the first Vj, which is a V1 star. That is the highest value in that column. You can tell me the highest value in the first column of numbers, the payoff. The highest value there was what? Abbas, correct. That is 100. What about the second column? The highest value there. Some of you will want me to go and show you the data. This is the data. What's the highest value here? 100. And the second one, what is the highest value there? 30. So this is also 30. Now, with that in mind, please keep the 100 and the 30 in your mind, because I'm not going to be moving page by page. What we are going to do now is I watch the formula. We have to take the highest value minus that number to get a regret. So we have to create a table called regret table. Watch it. So I'm going to create a table like this. Watch what I'm doing here. I'll call here S1, sorry, D1, D2, and then D3, and then S1, and then S2. So I'm going to find a value for the first item. Okay. I need to find a value for this. I need to find a value for this. That's what makes up the regret table. And what is the value? The value is the highest value minus that number there. So let's take the first one. The highest value in this column is 100. Minus the first number here, 50. That should be the number that will be put down here. So what number will be that? Okay. So between D1 and S1, the value will be what? The highest value minus that, 50, very good. Then still stay on that column. The next number, 100 minus 100, will be 0. The next number, 100 minus 30, that will be 70. Then you go to the second column. The second column, what was the highest value there? The second column, what was the highest value there? 30, very good, correct. So because it's 30, what will be the first number here? What will be the second number here? What will be the third number? Okay, so let's go with the first number. The first number will be what? 0, correct. The second number will be what? Be careful there. The second number, D2S2. What will be the second number? Excellent, very good. You guys are doing fantastic. So that will be 70, because it will be 30 minus 40, which is 70. And the last one will be 30 minus 10, which is 20. So this is called your regret table. Please note that sometimes the state of nature are many than what you are seeing here. You can have state of nature S1, S2, S3, S4, S5, S6. Okay, so that means you have to take your time and calculate all. Now that you have gotten your regret table, you are going to now continue to use it to determine your decision. Remember, you are deciding based on it. So the approach is known as Minimax regret. So we ignore the value and deal with the what? The regret. No more the value. Now let's focus on the regret. The next is to find the maximum regret. Remember, the word is Minimax regret. So let's find the maximum regret before we find the minimum of that maximum regret. So let's go to this column, maximum. So between under decision alternative D1, which is the maximum regret there? What is the value of the maximum regret? Decision alternative D1. There are 2 regrets there. Which is the maximum? 50, Alberta. Excellent. So the maximum regret is 50. What about the next one? The maximum regret, 70. Very good. What about the next one? The maximum regret, 70. Very good. So between 70 and 20, you select 70. Between 0 and 70, you select 70. Between 50 and 0, you select 70. And now, out of these 3, which one is the minimum? It is 50. So you write that 50 here, all in the table. Therefore, this 50, what is that? Who can tell me? Who can raise a hand and tell me what is that 50? What is that 50? What is that 50? Who can raise a hand and tell? What is that 50 value that we have here? What does that mean? What is it referred to? What is it? Yeah. Apartment, no. I'm not talking, what does it mean? I mean, what is the 50? What is the 50 what? 50 what? Is it 50,000? Is it 50? What does the 50 mean? That's what I'm asking. No. To me, that's not the answer I'm looking for. Yes, Princess.
Please, I have two questions. The first one is the
Answer my question before you come to your two questions.
Oh, sorry. I don't know.
Thought you were raising your hand to answer that. So let me quickly address that. So the 50-year refers to the lowest regret. The lowest regret. The minimum regret. That is why you are going to choose the apartment building. Okay? So somebody says the recommended decision, that's how you write. The recommended decision is to go for D1, which is apartment building. Why? Because it has the lowest of all the highest regrets. That is it. All right, Princess, ask your question.
Please, my first question has to do with the S2. When we were looking for the decision, you said it's 70. I thought minus 40 minus 30, but I said minus 40 minus 30. So please try to explain that.
Remember, the value, the thing is supposed to be the highest value, which is a V2 star, minus the VIJ. The V2 star is 30. The V2 star is the highest value in this column, and the highest value in that column is 30. And then the VIJ is minus 40. So it will be 30 minus 40. That's all.
Okay. Yes, okay. And then please, that's okay. And then the second one is the minimum. Like I thought minimum means small, but I chose 50. Please why?
You thought minimum is what?
Small, like the least.
The list of what here? The list of what?
You said from the decisions, the least one here.
Okay, so tell me the other ones that are there apart from 50. What are the other ones?
Oh, okay. You chose it from the maximum. Where you got the maximum? Okay, I get it now.
All right. That's also why I took you there. Sometimes when you miss slightly, you'll get lost in the way. All right. So using the minimax regret approach, the recommended decision is apartment building. So using 3 approaches, apartment building has been selected twice, office building has been selected once, warehouse has not been selected at all. Any question on this before we go to the next approach? Any question on this? So these 3 approaches so far we've looked at, okay, these approaches are known as decision making without probabilities, okay, without probabilities. And the last one, you have to create a regret table. Note, the word regret table is also known as opportunity loss table. The regret table is also known as the opportunity loss table. Okay, let's move on. In all of these approaches we've looked at, we were not assigning any probabilities to the state of nature. I'll repeat this sentence again because it's very important. Okay. We were not assigning, okay, that's the word, assign probabilities. Assigning probabilities to the state of nature, the SJ. What is the state of nature? The state of nature is the conditions outside the control of the decision maker. So the decision maker is assuming that the condition is going to be good, is going to be bad, but what shows is going to be good? What shows is going to be bad? What is the probability that it to be good? What is the probability that it to be bad? You can't tell. It's outside your control. So what do? You got to look for an expert with economic conditions, economic forecaster, who can foretell the future events happening. By the way, probability is between what numbers? Probability is between what and what? I think you've done, have you done probabilities? Judith?
It's between 0 and 1.
Okay, so that's percentage. Probability is basically percentage. So we have to assign probabilities, but you can't assign. You need to employ someone to assign that for you. Okay. So first thing I want you to take note here is this, that probability of the state of nature J is between 0 and 1. Take note. Probability of state of nature J is between 0 and 1. So if I have a probability of S1 to be 0.2 and the probability of S3 to be 0.4, what is the probability of S2? Who can tell me? What is the probability of S2? If you have probability of S1 to be 0.2, S2 to be 0.4, what is the probability of S2? S2. How you got the answer is important to me. Fantastic. All of you are giving right answers. Okay. So the probability of S2 is 0.4. How did you get a 0.4? Because S2 will be 1 minus the probability of S1, which is 0.2, and the probability of S3, which is 0.4. That is what gave us the 0.4. I want you to note that all the time, you will not know all the probabilities. You will miss one. You miss one of the probabilities. And because you miss one of the probabilities, you will have to determine that. Because probability is just 1 minus the ones you know. Okay. Now, if you employ an economic forecaster who is able to, so the sum of probabilities is always equal to 1. Using the real estate example, suppose Kofi Wayo is able to find out that the probability that economic conditions will be good, the probability that good economic conditions will prevail is 60%. Then what is the probability that economic conditions will be bad? Just type it for me. If the probability that economic conditions will be good is 60%, what was the probability that economic conditions will be bad? 40%. Wow, fantastic. Okay. So now we are assigning probabilities. So we'll go back to the table and please watch. We're going to assign probabilities to the state of nature. So whenever I see S, I'm going to do 0.6 there at the top here. And I'm writing 0.4, okay, because you've calculated it. So now each state of nature has an assigned probabilities. On the basis of that, here comes the next question. The question is, what is the recommended decision using the expected value approach? What is the recommended decision using the expected value approach? Okay. What recommended decision? Recommended decision. Which one are you going to decide on using a new approach here? Using the expected value approach. Please note this word. The word expected always carries with it probability. So you will not be told that use probability to calculate this, but you have to know that because we are talking about expectation, it means that you will need probability to calculate. So that will require that they would have already given you the probability. And in this case, we know that 60% is for good, 40% is for bad condition. How do you calculate the expected value approach? Well, there is a way to calculate the expected value approach. It's a very simple one. The expected value approach for any decision alternative, DI, okay, is given by, it's very simple, but sometimes when you write it, the person might think it's easy. It's given by the sum, the probability times the sum of the sum of the values, the payoffs. Okay, so the sum of the payoffs, each payoff, the payoff is VIJ. Each payoff is VIJ. Okay, so VIJ I sum them. Multiplying each VIJ, multiplying the respective probability of the state of nature, J. So this is it. What does this mean? It sounds like Hebrew. Oh, don't worry, you get it. So if I were calculating the expected value for decision alternative 1, what I need to do is this. I need to first of all know the probability of the state of nature. Remember, when you look at decision for D1, it is in columns. Okay, you can see it here. It's in columns. So I just need to multiply the 0.6 times the 50, the value, plus the 0.4 times the value, 30, plus the point whatever else is there times the value. So you're multiplying each probability of the state of nature by the respective payoff. And then you sum the answer. That's all. Multiply each by their respective payoff, then you sum the answer. So let me do the first one for you. Okay. So the expected value for D1 is going to be 0.6 times the expected value. The value was what? Is it 100? Okay. What is that? 50, okay, 50. So 0.6 times 50 plus the next one was the state of nature 0.4, the probability was 0.4 times 30. And then you put the answer down. I want you to calculate the expected value for D2. And then I want you to calculate the expected value for decision alternative 3, warehouse. Calculate for each one of them. Find me the first one and calculate for the other ones. Raise your hand if you got something. Find me the first one and calculate the other ones. So what you are doing is known as the expected value approach. It is also sometimes called expected value without perfect information. Without perfect information. Yes, Freeman. What did you get for the D1?
All right, Doc. For D1, I had 42.
Okay, that's what I want
And
first.
for-
Hold on with the others. Okay. Guys, the reason why I'm holding on slightly is I want all of you to calculate. The other point. You know, somebody is there, the person is not calculating. When you are calculating, when you are doing it, when you are writing it, you make mistakes. As you make mistakes, they help you to be able to do it when it comes to real situations. Okay, Freeman, give me the next one. Expected value for D2.
Okay,
Tell me how
so
you work it.
All right, so for D2, we pick 100 and multiply by the probability of 0.6, plus then we pick the next value, which is -40, and multiply by the probability of 0.4. And that gives you 44.
Good. The third one.
So the third one, so you pick the value, which is 30, multiplying by 0.6, plus 10 times 0.4. And that gives 22.
Very good. Excellent. So, ladies and gentlemen, using this fourth approach, expected value approach, which decision alternative will you go for? Remember, this is value. This is value. Which alternative, which decision approach? Is it apartment building that you're going to invest in, or office building, or you're going to select the warehouse? Which one? Which one will you go for? Based on the expected value approach. Excellent. You go for office building. Go for office building because it gives you the highest expected value. It gives you the highest expected value. So using the 4 approaches, 2 say we should go for apartment building, 2 say we should go for office building. So far, warehouse has not been selected. Now, remember that when we were computing the expected value approach, we had probabilities of the state of nature. You remember? We had probabilities of the state of nature. And I also did mention that the expected value that we have calculated is also known as expected value without perfect information. Take note. Let me write that down because this is important. So the expected value approach is the same as, okay. If your hand is up.
Yes, sir. I'm sorry to take you back, but I was just wondering, when we were getting the probability, we know that the state of nature is S1 and S2, but then you introduced S3, and that's helped us in calculating for S1 and S2. I wanted to...
I didn't introduce S3.
They said if... So
I said it could have been more.
Oh. Okay.
There could have been S3, there could have been S4,
yes,
there could have been S5. Right. There could simply have been more, yes. But the one we have here is just 2.
Okay.
All right.
And then we assumed for one and then calculated for the other.
Exactly. So if you have 5 states of nature, you'll be given 4 of them, and you will have to find the others.
Look for one. Yes, sir.
But let me trick you. Let me trick you. Suppose you have state of nature 1 to be 0.2, state of nature 2 to be 0.25, state of nature 3, no, state of nature 5 to be 0.25. State of nature 5 to be 0.25. What should be state of nature 3 and state of nature 4? So this one, you're not finding 1, you're finding 2. What should be the state of nature 3 and state of nature 4?
Okay, so
of course, under certain conditions though, but the conditions would have been given. Under certain conditions, what would be 3, what would be 4? Mind you, your colleagues have raised their hands, which means they are waiting for you.
Hey, they should hold on. So state of nature 3 and state of nature 4 both together will be equal to 0.3. And so if the 2 of them will be equal to 0.3, I don't know how I'm going to get either one of them.
Okay.
So maybe those who have raised their hands can help me.
Who has something to say? Raise your hand because the answers are not correct. The answers some of you are writing are not correct. Somebody says 0.15. Okay, so when you add these 2 together, you get 0.5, and therefore you have 0.5 there, and you add that to this one, you get 0.7. So you are left with 0.3. Under that condition I indicated, it means that these 2 will give you 0.3, okay, which means that each will give you 0.15. That's all.
Okay, so this is assuming that state of nature 3 and state of nature 4 are equal.
That's it. That's what I mean by under certain conditions. That's what you just indicated. I'm just trying to let you know that it's not all the time that you will have only one of the state of nature given to you.
Okay. So I'm just asking, in an exam, if you give me this one, it will be safe to assume that the 2 that I'm looking for.
I will give you the assumption, don't worry.
Yes, sir. Thank you.
If I don't give you the assumption, you will all assume differently.
Yes, sir.
All right. So
thank you.
Okay, welcome. So let's go to the expected value of perfect information. So I already told you guys that the expected value that we calculated some few minutes ago, that selected office building, is also called expected value without perfect information. You remember that? Okay. Now, the next thing that we are going to find out today is known as the expected value of perfect information. The expected value of perfect information. Now, how do I write that? Now, the expected value, yes, Isaac, your hand is up.
Yeah, Doc, please, before the probability question came in, you made a statement that the expected value approach is the same as you were making a statement, but you paused and brought in the assumption that we worked. So please, if you remember that.
The expected value approach is the same as expected value without perfect information. That's what is on the screen. You get it now? So it's the same thing. So when you hear expected value without perfect information, is the same as expected value approach. Okay, now we are going to find the expected value of perfect information. The words are going to be quite murky. That's why I'm taking my time. We are going to find the expected value of perfect information. How do you get expected value of perfect information? Well, first of all, there is no way you can find expected value of perfect information unless you know the expected value with perfect information. So this is what I mean. The expected value of perfect information is the absolute value of expected value with perfect information minus expected value without perfect information. Write it down, right? You write it down.
Please come again.
Now that's why I'm saying write it down. The expected value of, the word of is important, of perfect information, EVPI, is given by the expected value with perfect information and the expected value without perfect information. Now, first of all, let me explain what I mean by perfect information, without perfect information, and all of this. Let me explain that. Information in business, in life, in everything is important. If we knew that COVID-19 was going to strike in 2020, as at 2018, if we had that information, we would have acted on that way ahead of time, quarantined people, and then would have sorted the thing way ahead of time. Information is important. Information is important in economics. Information is important in health. If you can identify and decode the problem of cancer, of leukemia, if you can decode the molecular genetic codes of certain diseases, you can stop that from happening. Information, perfect information, is important. When you are in a government, information is important to win or not to win an election. Information is important to win a war or not to win a war, to stop a war, to administer peace. You need information, especially if it is perfect. So if a president is supposed, if you witness a president killing someone, and you go to the television state and you say, I saw the president killing someone, who just died. Nobody is going to believe you. They will ask you, bring your information evidence. So suppose you took a video of the whole matter, that makes it concrete information. So people go ahead and even buy information. People blackmail other people for information. So Kofi Wayo is saying that the probability of the state of nature becoming good is 60%. That's what we saw earlier. The probability of the state of nature becoming bad is 40%. How factual is that information? If there was a way, let me ask you guys, if there was a way you can buy information right now to you are so positive, you buy an information about what is going to happen to you in 5 years, and it is clear that you have, and the price of the information is maybe $1,000, and you are sure that that is the information about you, and you can use that information to achieve something, wouldn't you buy? If someone is blackmailing you with an information, wouldn't you tell the person to drop that? So information about future events are good because they help us to make decisions. They help us to do that. And suppose Kofi Wayo were to hire an economist, okay? You hire an economist to give you perfect information about the state of nature, exact state of nature. What you will do is that you will pay for that, won't you? But let me tell you, will you pay more than the information can help you? Will you pay more than the gain you can get from the information? Suppose the information is going to help you to make $100,000. Will you pay $200,000 for that information? No way. So the information has value. It has a maximum value. And the maximum value must match the maximum cost. Listen, the value of the information can be calculated as an expected value. Therefore, we will come out with the value of the information. This is what is known as the expected value of perfect information. That is it, the expected value of perfect information. So the expected value of perfect information is the value of the information that you have that will help you to achieve whatever you want to achieve. So if you have some amount to pay, okay, if you have some amount to pay, or you have some, if somebody has some information and the person tells you that you should pay, he will give you that information so that you can detect clearly what the economic condition is going to be. You will pay that amount. So the amount of money you are willing to pay for that information is the expected value of perfect information. Is the expected value of perfect information. But you see, you can't get that expected value of perfect information unless you have a certain situation, unless you have expected value with and without perfect information. So what is the value with the information and what is the value without the information? That is what we are going to calculate now. We are going to first calculate the expected value with perfect information. If I have perfect information, then we'll compute the expected value without the perfect information. Now remember, the expected value without the perfect information, we have already calculated that. We call that EV. And we had that to be 42. Now, we need to find the expected value without perfect information. If we did not have the perfect information, what would be the value? Now, to get the expected value without perfect information, there is a formula to getting that. And how do you get that? The expected value without perfect information will require the maximum value in the first place. So how do you get that? So it is the, so let me write it here. The expected value without perfect information is given by the expected value or the sum of the probability of the state of nature J, don't get confused, multiplied by the maximum value, Vj star. maximum VJ star. Yes, Isaac, I saw your hand.
Yeah, Prof, you keep saying expected value without perfect information.
Yeah.
But I thought we are now calculating the expected value with perfect information.
Yeah. Okay, so I told you that be careful of the choice of words I'm using. You gotta listen. The expected value without look, that 60% and the 40% we had is not with perfect information. It was just information that someone is telling us that the probability of the state of nature is going to be 60%. So it's not with perfect information. The information is not perfect. The information that you use to calculate that EV is not perfect information. Now we are going to calculate the expected value with perfect information. How do you calculate the expected value? Go ahead.
Yes, I get it now. But initially you were interchanging it. That's why I was quite confused.
I have not interchanged it, to be honest with you, unless you know.
Okay.
I was very careful with my choice of word. There is expected value of perfect information with perfect information and without perfect information. Just take note that you cannot get expected value of perfect information unless you get it with and without, unless you strike the difference between the with information and without information before you can get it off the information. You see, if I said that, if you don't take it, you'll be confused. And that confusion is what lingered behind your mind before asking this. So what I'm saying is that the 42 that you had, it was an expected value, all right, but it was an expected value for one of them, office building. There was another one for apartment. There was another one for, warehouse. They had different values depending on the different state of nature and then the different payoffs. But now we need one singular expected value with perfect information. How do you get that? You get that one singular one using this formula. And this formula says that take the S1 column and take the S2 column. S1 column has got probability there. S2 column has also got probability there. S1 column has got the highest value there. We call it V1 star. S2 has also gotten the highest value there. We call it V2 star. You get it so far? Now, take the probability of the state of nature for S1 there. So S1, what is the probability there? It was 60%. Okay, 0.6. S2, what was the probability there? It was 40%. Okay, good, 0.4. What was the highest value in S1? It was 100. Do you remember? There. Remember, S1, S are columns. And what was the highest value of S2?
30.
It was 30. So the expected value with perfect information will be the 0.6 multiplied by the 100 plus, the plus is a summation, by the way. The plus is a summation, plus the 0.4 multiplied by the 30. And that will give you a single value. That value is, you are not using that value to decide. Remember, each thing we have calculated, you were using each one to make a decision, to make a decision, to make a decision. This one, you are not using it to decide. You are only using it to help you achieve something. So it is encapsulating everything, expected value, weight, perfect information. What do you get? When you multiply, what do you get? Let me see. When you multiply from the 60, then you do this one.
72.
That's 72. Okay. So you get a value of 72. That is the expected value with perfect information. Is the value, taking everything into consideration with perfect information. That's the value you get. Now, given this value, you cannot calculate your expected value of perfect information. What is that? I'm talking about this one here of perfect information. You can calculate EVPI. How do you calculate that? We are told that is the absolute value of the one.
Sir, please, are you writing on the board?
Yes,
because
I am.
I'm not seeing anything. I only have.
Don't worry. Let's ask your colleagues whether they are not seeing anything as well. Do you all see
anyone
nothing?
seeing? There's nothing. No, it's just the formula that has been there. But I see you busy writing.
Please, the rest of you, are you seeing the same situation? Talk. I want you to talk.
I can see you writing.
We can see what you are writing.
Yes,
now
Doc.
I can see.
We
Now
are
the
seeing
page
what you are writing.
Yes, please, we can see.
Hey,
So
okay.
She seems to not have perfect information. She was so confident she had perfect information, but she did not have perfect information.
By this, I should automatically understand.
Because once
Okay, so
everybody
if
had perfect information, she had an imperfect
sorry, sir,
information.
Yes, but just to recap, I'm now seeing it, so it's now sort of making sense. Would you mind just going through for the last time? I've seen the equation, I've taken a shot of it. So if you can just quickly go over. I'm a quick learner, so I'll grab it.
I indicated that the expected value of perfect information. Watch my words, because I use words, but if you don't take it, you will not know that I've used off. I have used with. I have used without. The expected value of perfect information is the value of the price you pay for perfect information. Is the value of the price you are willing to pay for perfect. Is a value. Is a value of the price you're willing to pay. And that one, this one is given by the expected value with perfect information. So this expected value with perfect information is like a hypothetical perfection. You know, for example, you know, the daughter I'm going to give is, you know, the baby in my womb is a girl, is a boy, is a girl, is a boy, is a girl, is a girl. But, you know, at the end of the day, when the baby is born, we know perfectly. But until we know, we only make a perfect assumption, thinking that we are correct with that. That is it. This is it. Expected value with perfect information. And then the expected value minus the expected value without perfect information. The expected value without perfect information, I've already given you. You have to calculate that for each one. Each one. So we did it for D1, D2, D3. We have 40, 42, 28. Something. And then we put that down for each one of them. And we selected the 42. The expected value with perfect information require that you are taking the maximum value, because at the end of the day, if you have perfect information, you go for the maximum. You will go for the maximum. And so you will use the maximum value in each state of nature. That is a V stars. So V1 star, the maximum value there is 100. Okay. V2 star, the maximum value there is 30. You multiply each one by their respective probabilities. Whatever you get is a one figure, and that figure is 72. And that figure is expected value with perfect information. Now, we can calculate expected value of perfect information. It is expected value with perfect information, the absolute value of this. Expected value with perfect information, which is 72. Okay. 72 minus the expected value without perfect information, which was a 42 that we selected. And when you do that, you're going to get 28. So that 28 is a value that you see, that 28 is a very important value. That is a price you are willing to pay. If somebody tells you that I have the best information that will help you to achieve the maximum return, and that is the price you are willing to pay, because you will not pay more than 28, because you know the expected value of that perfect information is going to be 28. Now, that's it. The last thing I want to share with you.
So I have a question.
Yeah, go ahead.
So when we're calculating the perfect value without, the value without perfect information, the highest value we had was 44. I don't know if I'm correct. That was for D2.
Oh, it wasn't 42. Oh, it was 44.
No.
Sorry, it's supposed to be 44. And so this value here is supposed to be 44. And a 72 minus 44 will give you what? So please check and then confirm.
28.
It's 28. I think I had the actual correct answer in my head. So yeah, so you're right. It's supposed to be 44 for office building, not 42. Yes, Amma.
Yeah, sir. Meaning that from where we started calculation to the very last end, I've seen that we've not used the regression table anymore. So that means it's not needed, because
We are now going to use that one in the last angle. The next one I'm about to.
Okay, so it depends on the question that you have.
Exactly.
And you know which of the tables. Okay, thank you.
And as the name sounds, it's a regress table, regret table. So regret means something you don't want. So anytime there's something you don't want, when we are talking about things we want, for example, we are talking about things we want, which is value. So when we're talking about things we don't want, which is regret or loss or things like that, remember, I'm using the word regret or loss, regret or loss. If there's anything like that, then the regret table comes into the picture. Now, if it is about value, we are not using the regret table. When I finish, I'll summarize for you to know technicalities. All right, so the last thing I want to look at is known as expected opportunity loss approach. Expected opportunity loss approach. You see, life does not reward you according to your definitions. Life rewards you according to the quality of your definitions. So when you understand something well, it helps you to be able to move on with other things. I told you some minutes ago that the expected value approach, remember, expected value approach is the same as expected value without perfect information. Do you remember? Some few minutes ago, we just calculated the expected value of perfect information. Do you remember? And we said the expected value of perfect information was 28. You remember? Okay. And we also did mention that that expected value, watch the word, is value of perfect information. It is the amount you are willing to forego, to lose, to get perfect information. And now we are talking about what is expected opportunity loss. So the expected opportunity loss, the amount you are expecting to lose, will obviously be equal to the expected value of perfect information. If you don't get it, you let me know. I'll go over that. It's not about I'll go over that because you don't get it, but you don't get it. So I need to go over that. If you don't get it, that can.
Yes, please go
over it. Please,
right.
Please go over.
So the expected value of perfect information, some few minutes ago, I told you that the expected value of perfect information is amount, value you are willing to give for perfect information. Value you are willing to give someone if the person promises you to get perfect information towards your achievement. But that value you are willing to give, because you are giving that value, is not going to you, it's going to that person. So to you, that value is what? It's a loss, isn't it? It's a loss. Now in this calculation, we had that value to be 28. Now we are going to calculate something known as expected opportunity loss. What is that? It is the amount or the costs that leaves you. The cost that leaves you. The loss you incur for achieving anything that you want to achieve. And who is going to help you to achieve that anything is the value that somebody said that will give you perfect information. Therefore, the expected value, the expected opportunity loss must always be equal to the expected value of perfect information. I have not calculated the expected opportunity loss yet. I'm about to calculate. I'm about to show you how to calculate it. I want you to know that the expected opportunity loss is the expected value of the regret for each decision that you make. The expected value of the regret is a loss for each decision that you make. You got to write it down. It's the expected value of the regret or the loss for each decision that you make. You see, whenever you call something a loss, note that it's not a loss per se, it's also a gain somewhere. When you lose 20,000, someone is gaining that 20,000. But you are calling it a loss, but this COVID-19, some are complaining that we've lost money, that money has circulated and gone to some other people. Losses are gains, gains are losses. Out of chaos comes opportunities. Anyway, therefore, what is the expected opportunity loss? The expected opportunity loss is given by, so if I were to calculate expected opportunity, I need to know the expected opportunity loss for each decision. So expected opportunity loss for decision 1, for decision 2, each decision. It is given by the same probability of the state of nature, the same probability of state of nature J, multiplied by the regret for each decision. The sum of that. You write it down, don't worry. The probability of the state of nature multiplied by the regret. Why are we using the regret table now? Because we are dealing with what? Canton. Why are we using the regret table now? Why are we using the regret table? We are dealing with the loss.
Because you are dealing with loss.
Exactly. We are not dealing with value. We are dealing with loss. Expected opportunity loss is given by the probability of the state of nature. So that means that, first of all, I need to know the probability of each state of nature. We know that the state of nature S1 and S2 have got their probabilities, which are 0.6 and then 0.4. We know that. Now, each regret must be multiplied by that, depending on where they are showing in the column. So let's say that we are going to calculate for EOL for decision alternative 1. They're going to calculate that. The same approach you normally will calculate the EV, the expected value. At this time, we are using losses, so we use the regret table. We have to take the probability multiplied by the regret. The probability, and remember, I'm doing for D1. The regret table for that is this. Let me just show you the regret table. It's not difficult. The only thing is that you have to keep track of them. That's all. So the regret table says 50 and then 0. The other one is 0 and 70. The other one is 70 and 20. So let's deal with the first one, 50 and 0. So you're going to take the 0.6 multiplied by the 50. Then you take the 0.4 multiplied by the 0. Then you sum them. That will be for D1. Okay. So let's go and do that. So the probability is 0.6 multiplied by the regret, which is 50, plus 0.4 multiplied by the regret, which is 0. That will give you the expected opportunity loss for D1. Then you calculate the expected opportunity loss for D2. Then you calculate the expected opportunity loss for D3. Do that. And as you do that, let me just take you back to the table. Remember that we were able to calculate the expected value too for D1, D2, D3. And that one we used it to decide. That one we did it here. Expected value, we did that here. And we chose the highest value. Choose the highest value of 44. This time we are dealing with the regret. So let's go to the regret table. So who has done the first one? Okay. The expected opportunity lost for D1. Okay, what did you get? Yes, Nyako.
It's
Go ahead.
Okay, Doc. So for the first one, the 0.6
Give me the
expected
final answer.
opportunity.
That's what I mean.
Okay, 30.
Okay, so the first D1, you get 30. The second?
Yes. 28.
The third?
50.
Okay, so EOL D3, you get 50. Which one will you select?
I will select the lowest, which is 28, because we are dealing with costs.
You are dealing with losses. Very good.
Losses, sorry.
So that is it. So selecting this 28, if you are told, you have to use the EOL to decide on which alternative you are going to choose. And in this case, you will not choose the highest, you choose the lowest because it's 28. Now, what does this 28 remind you of? Who can tell me? And what does that mean then? I've been asking this question all the time in an exam. What does this 28 here remind you of? What is the implication? Yes. Yes, Isaac.
It was the amount we decided to forego in order to get perfect information.
So
therefore, the expected opportunity lost is equal to the expected value of perfect information.
perfect, excellent, well done. That's it. In other words, you will not pay more than or less than for any information. You will not want to lose any amount that is not equal to the information that you are going to get for whatever achievement you are going to achieve. The perfect information, you will not pay more than the perfect information that you are going to get. And therefore, you are willing, all right, to lose that 28 because that is the exact amount that is going to give you the value that you are looking for. The expected opportunity loss occurs because the regrets, remember the regrets is what we use to calculate that. The regrets will show or they reflect the difference between best decision and actual decision. best decision and actual decision. And that's what we're doing. So please note this, whether we are dealing with a maximization or a minimization problem, expected opportunity loss, okay, is the best alternative that you have to deal with. Is the best alternative. What I mean by this is that it is the minimum value that you are going to choose anytime to be able to achieve the, because we are dealing with, what we are dealing with here is a maximization. And yet we are not going to say that because we are dealing with a maximization, we are choosing the maximum value. No, whether you are dealing with a maximization, you always deal with the minimum value of that expected opportunity. All right. So which decision? Now, so this final one, this number 5, we were able to choose expected opportunity loss of office building. Office building was the best decision that we went for. Okay. So office building has won 3 times, and apartment has won twice. Remember the EVPI, that one was just to know. It was not to decide. Please let me show you something. You always decide when you are calculating something for each decision alternative. So when we are calculating expected value with perfect information, that one, we did it for all of them put together. We didn't do for D1, D2, D3, perfect information. But when we're doing for the without perfect information, which was the EV, we did it for D1, D2, D3. So whenever you do for D1, D2, D3, D1, D2, D3, D4, D5, whenever you're doing for each alternative decision, that is when you use to decide with. But not when you are calculating for expected value of perfect information. You don't use that to decide. So what do you see about, and this is very important, what do you see about these two? Expected value, let me go back to that portion there. Expected value of perfect information, expected opportunity loss approach, and then the expected value approach. There's a connection. What do you see as the connection? I know I've already, Isaac has already given the connection between the expected value of expected opportunity loss and then expected value of perfect information. Okay. He said that they lead to, the selected value here will always be equal to the EVPI, 2828. But what can you tell me about the outcome, the relationship between EOL and EV, looking at your own results? What can you say? Now, normally you can't say anything except when you look at your results you have, or the decision outcome, or the recommendation. What would you say about the expected opportunity loss approach and what it gave us eventually? And then the expected value approach and what it gave us, because both of them we use it to decide. What do you say? Exactly, Francis, that's the right answer. Okay, it means that they led to the same decision. And that is the point I want you to take note. So if you are in an exam situation or anything and you're calculating and you realize that the expected value approach chose decision 13 or decision 4, but the EOL chose decision 5, you should know that you are wrong, because they should lead to, both approaches use probabilities and both approaches will lead to the same decision. I want you to take note of that. All of these are in the slides, by the way. Okay. So it's important that as a decision maker, you are as accurate as possible whenever you are determining the probability of the state of nature. So there are several of these examples that you can look at. Okay, now let me show you something. Okay, let me show you something on your screen. If you can see the screen, let me know. This was an exam question you were asked some time ago. Do you see the screen? 2012, 2013.
No.
No.
Okay, this is
Please.
No, we don't see it.
All right. So now this was a bit of an exam question in 2012 and 2013 academic year. This was their question. A BTA publishing company publishes management science textbooks that is scheduled for a revision. The book has been moderately successful, but each year more new books enter the market. So some of them are dropped by the publishers, and the various innovative pedagogical approaches are introduced by the authors, such that the competitive market is always highly uncertain. Now, the role of the internet is making it very difficult to know what book to give. So the company is trying to decide whether to publish the next edition of the management science book as a paperback, SPB, paperback, as a new edition to be very similar in size and content to the current edition. So the next decision is SSC. And then they want to know whether to revise the book with emphasis on linear programming and network flow. Okay, that's the next decision. Or finally, to make major revision on physical changes, including color and graphics. That is BCG. Okay, so here is a table. You have a table given this way. So you have all of the situation. So if they go for the paperback under unfavorable condition, okay, the payoff is going to be 68,000. Under the same competitive market condition, it will be 170,000. And under favorable conditions, it will be 395,000. And then you have this situation. What do you see about this as different from the one we had before? What is the difference between this and the one we have worked for? Anyway, in the example, what is the difference between this one and that example? Rita Kusi. Okay. Beauty. Alberta, one of you should give me the answer. What's the difference between this question and that one? I hope you see the screen very well. Yes, Rita. Yes, Kumi.
We have 3 states of nature here.
Mm-hmm.
And then 4 decision alternatives.
Good.
To be made.
So the decision alternative and the state of nature have all increased. Okay. And look at the kind of questions you were asked to deal with. 1, determine the best decision for the publisher using the Minimax and the Maximin approaches. Okay. So it's actually supposed to be Maximax and the Maximin approaches. The second question is determine the best decision using the Minimax regret. That is opportunistic approach. Next is you are told that suppose the probabilities of the state of nature are 25 and then 42%. So you can see that the state of nature for S1 was not given. S2 was given, S3 was given. Okay. And you are based on that, you are supposed to decide using the expected opportunity loss technique. Finally, you have to find the expected value of perfect information and compare your results with the expected opportunity loss. You should be able to crack all of this in a little time. So that is a sort of thing that you should, you can look at the textbook, and there are several of these examples as well for you to do. All right, any question? Any